you're going to continue the matrices. Today we are going to look at the multiplication. That's operation for multiplication. Yesterday we concentrated with the addition and subtraction. So let's look at the multiplication. So I wanted to just continue by saying multiplication. The main rules is that for it to be possible to multiply two matrices, the number of columns in the first matrix, should be equal to the number of rows in the second matrix. For instance, should be equals to the number of rows in the second matrix. For instance, 2 times 2 and 1 times 2. 2 times 2 and 1 times 2. Now, I want you to look at this particular two, the matrix. This is 2, the order of matrix is 2 by 2, which means we have 2 rows and 2 what? Columns. When you come to this one, we have 2 rows, we have 1 row and 2 columns. Now this one cannot be multiplied. When you find the columns like this one, then you cannot. So you continue by saying cannot be multiplied because there are 2 columns in the first. There are 2 columns in the first. There are 2 columns in the first and 1 row in the second, and 1 row in the second. On the other hand, 2 times 2 and 2 times 2 and 2 times 1. 2 times 1. So you have already changed this one. Now 2 times 1. So it can be multiplied. And it should give 2 times 1 matrix. And it should give 2 times 1 matrix. Should give 2 times 1 matrix. So I want us to look at this example. You write A equals to matrix A. A will be equals to 3, 1, 2, 4, 3, 1, 2, 4, 7, 4. That is the first matrix. Matrix B equals to 8, 8, 0, 5, 4, 0, 5, 4. Then 3, 2, 1, 1. 3, 2, 1, 1. 3, 2, 1, 1. Now, first, before we multiply this one, let's find out the order of the 2 matrices. The order of the first matrix is going to be 3 by 2 matrix. The order of this particular matrix is going to be 2 by 4 matrix. We are together? 1, 2, 3, 4. Now, when you look at this particular matrix, you're going to find that, look at the column in this particular matrix. We have two columns. Look at the row in this matrix. We have two rows, which means this one you can multiply. So when you are told to multiply this one, then you're going to say that A times B. So let's do that. So that's going to be 3, 1, 2, 4, 7, 4 times we have 8, 0, 5, 4, 3, 2, 1, 1. So when you multiply this particular matrix, then always I use the word Roman Catholic. I use the word Roman Catholic, which means we are going to multiply the row times the column. You multiply the element in the row, you multiply by the element in the column. You're together. So these are the elements in the row, and these are the elements in the column. So that's why I say it's going to be the Roman Catholic. The first matrix is going to be for the Roman. The second one is for the Catholic. We're together. So we multiply this times this plus this times this. So let's do that. So in this particular case, the new matrix is going to be 3 times 1. Sorry, 3 times 8 plus 1 times 3. We repeat the same row. It's going to be 3 times 0 plus 1 times 2. The same row. 3 times 5 plus 1 times 1 plus 1 times 1. Then we go to the next row, the same row, 3 times 4 plus 1 times 1. We come to the second row now. That's why I say Roman Catholic. I come to the second row. I take 2 times 8 plus 4 times 3. Then 2 times 0 plus 4 times 2. Then 2 times 5 plus 4 times 1. Then 2 times 4 plus 4 times 1. Now the third row now, I start again. 7 times 8 plus 4 times 3. 7 times 0 plus 4 times 2. Plus 7 times 5 plus 4 times 1. 7 times 4 plus 4 times 1. Get together? Then that's going to give us the new matrix. What is our new matrix? So 3 times 6 is 24 plus 3. 20? 27. 3, 0, that is 2. Get together. 15, 16 for someone. That's 12, 13. We come to the second one. That's going to be 16. 16 plus 12, 28. That's going to be 8. 10 plus 4, 14. 8 plus 4, 12. This 54, 50 what? 56 plus 12, 60, 68. That is 8. That's going to be 35 plus 4. 7, 28 plus 13. So this is the new matrix. So I want you to observe this new matrix and look at the first matrix. So when you look at the first matrix and the new matrix, the row of the first matrix will be equals to the row of the new matrix. I hope you are getting that point. And the column of the second matrix will be equal to the column of the new matrix. We are together. So in this case, under the multiplication, now the new matrix will take the row of the first and the column of the second. We are together. I hope you are together there. Now, so you continue by saying NB, number 1. The size of the final matrix, AB is 3 times 4. 3 times 4. That is, it has the same number of rows of A, the same number of rows of A, and the same number of columns of B. The same number of columns for B. Two, A times B is not equals to B times A. I hope you're getting the point. When you start with this one, you cannot take this to multiply by this. But you can only multiply this one times this. Because you look at the column versus the row. We have 2 columns and we have 2 rows. When we interchange this one to be the first one, so we are going to have how many rows? 4 rows. And how many columns? 3. So you continue. Number 3. If AB is possible, then it does not necessarily means BA is possible. Does not necessarily means BA is possible unless the 2 matrices A and B are square matrices. Unless the 2 matrices A and B are square matrices. Now, only square matrices is the one you can interchange and still you multiply. But when you talk about the rectangular matrices, you cannot. If A and B, if A can multiply B, then B cannot multiply A. So I hope you're together there. Now, before we continue, we want to look at the Tuliangalia determinants yesterday? No, it's not this class. Before we continue, I want us to just do for me this one very fast, and then we continue with what we are doing. Let's continue. That question. Now, let's continue. We are going to look at the determinants of a matrix. Determinants of a matrix. Now, how do we get a determinants? So we are going to look at the determinants of a 2x2 matrix. So you continue by saying, this is a scalar matrix. This is a scalar matrix. It's a scalar matrix obtained from the elements of a matrix. Obtained from the elements of a matrix by a specified operation. By a specified operation. This is a scalar matrix obtained from the elements of a matrix by a specified operation. By a specified operation. Which is characterized, which is a characteristic of a matrix. Which is a characteristic of a matrix. Remember, we talked about the scalar matrix, whereby we say that the scalar matrix is a matrix with it's a matrix. Okay. So we continue. The determinants is only specified. The determinant is only specified for a square matrix. For a square matrix. Now, the determinants is only specified for a square matrix. It simply means that when the matrix is not a square, you cannot obtain the determinants of that particular matrix. Only the square matrix is the one you can obtain the determinant. So we are going to look at for a 2x2 matrix. 2x2 matrix. That's the one you're going to study. Now, assuming that we have a matrix A, which is going to be A11, A12, A21, A22. This is a square matrix of 2 by 2 matrix. Now, if you are told to find out the determinants of this, then we are going to say that the determinants of A, which is you write it like this, or you can write it A, that will be equal to the product of leading diagonal minus the product of secondary diagonal. So this one is going to be equal to, what is our leading diagonal is this one. So it's going to be A11 times A22 minus A21 times A12. So that is the determinants here together. So that is going to be our determinants. Now, let's find out the determinants of this matrix. That is A will be equal to 89, 6, negative 5. So if you want to get the determinants of this particular matrix, then you are going to say that the determinants A will be equal to the leading diagonal is this. So it's going to be 8 times negative 5 minus 6 times 9. It's going to give us negative . Negative 51. This times this negative. This times this 50, 54. Yeah. So this one and this is going to give us what? Negative 54. Get together. Okay, let's continue. I just want to get for me this one. Find the determinants of F equals to, find the determinants of F equals to 8, 4, 11, 5. Find that one. Negative 4. Okay, let's continue. Now, let's look at the inverse of a matrix. Inverse of a matrix. We look at the inverse of a matrix. inverse of a matrix. So you continue by saying, if for an n times n, n times n, if an n times n, if an n times n, so you can an n times n, there is another n times n. There is another n times n. There is another n times n matrix B, matrix B, that the product is the identity matrix. That the product is identity matrix or product n times n, or product n times n. That is A n times n times B n times n. That is going to give us identity matrix of n times n. It's going to give us identity matrix of n times n. So you write inverse of a 2 by 2 matrix. Inverse of a 2 by 2 matrix. Now the inverse of 2 by 2 matrix is calculated by interchanging. Is calculated by interchanging. Calculated by interchanging the element of the leading diagonal. The element of the leading diagonal and multiplying the elements of the other diagonal, the element of the other diagonal by -1. Okay, the element of the leading diagonal and multiplying the element of the other diagonal by -1. By -1. The resultant matrix is then multiplied by the inverse. The resultant matrix is then multiplied by the inverse of the original matrix determinant. Or the original matrix determinants. Now, in this case, we are trying to look at this particular matrix. If your matrix A equals to A11, A12, A21, A22. If you are given that particular matrix, then you are going to say that the inverse of this matrix will be equal to the inverse, of the determinants of the original matrix, which is this one. The inverse here is going to be A. So it's going to be 1 over the determinants. We are together. Then we open the bracket. We take this particular matrix, we interchange this by saying A22. This is A11. We multiply this one by this by -1. So that's going to be negative A21, negative A12. So that is known as the inverse. We interchange this one. We multiply this one by -1. Then this particular, what we are going to get here, we multiply by the inverse of the determinant of the original matrix. They're together. Now, what I'm trying to explain, talk about, this is the original matrix. You know that the original matrix, the inverse, we always write it like this, A. Or you can write it as A cosine. So what's the inverse of this? This is the determinant. What's the inverse of this or inverse of this? It's going to be 1 over A. That's the inverse. They're together. So this particular inverse, now we look at the original matrix, which is this one, where we found the inverse. Then we interchange this one by taking this to be, this one to be here, and this to be this one. The remaining matrix, which is this and this, we multiply by -1 here together. So we are going to obtain this particular matrix. Then we multiply by the inverse of determinants. Then we get what's known as, that's the inverse of a 2 by 2 matrix. Question there? So you write that and then continue. If you get it at 7, so we take 1 over 7. Now let's look at example. B equals to going to be 2, 3, 1, 4. 2, 3, 1, 4. Now, when you're trying to get the inverse of this particular matrix, the first step before you get the inverse, you get the determinant of this. So what's the determinant of B? So B determinant will be equals to this times this, that's 2, times what? Minus this times this, which is 1 times 3, to give us 5. Then after getting the determinants of the matrix, the next step, now we are going to find out, we are going to interchange the main. So first we take this one as the determinants, we get the inverse of that, which is 5, you're together. Then you open the bracket now, you interchange this for 2. We multiply this one by -1, -1, negative what? 3, you're together. So that's going to be B inverse is going to be that, because now. So after getting that inverse, this is the same as 4 over 5, -3 over 5, -1 over 5, 2 over. Okay. Before we look at, let's look at the application of a matrix and then we continue. Application of a matrix. One, It's used in this, it's applied in the simultaneous equation. Simultaneous equation. To Markov analysis, Markov is this one. Analysis. 3, input-output analysis. Input-output analysis. That's going to be input, output analysis. The next one is linear programming. And then we have the games theory. We have the games theory. Now, before we solve the matrix, before we solve any simultaneous equation using the matrix method, now we are going to use the grammar rules, grammar method, to solve for the simultaneous grammar rules. Now, when you're trying to compute or to solve any equation using the grammar rules, now, what you're supposed to do, if you are given, I just want to give an example for matrix and then you solve it. Let's assume that you're given this matrix. Our matrix is going to be 2x minus y equals to 7. And then we have x plus 3y equals to 14. So if you're given a matrix like that, then you are told to solve this particular simultaneous equation using the grammar rule. So what you're going to do, the first step, you must make sure that you construct this particular simultaneous equation in a matrix form. That's step 1. You construct simultaneous equation in a matrix form. That's the first thing you're going to do. Then we come here, we take 2, -1, 1, 3. Now remember, these are x and these are y. They're together. Now, when you remember this is x and this is y, and remember how do we use multiplication? It is the Roman Catholic. They are together. So in this particular case, we arrange x and y like this. X, y will be equals to 7 and then 14. So for us to solve this particular equation using the grammar rules, the first step, I said, we are going to do what? Construct the simultaneous equation in a matrix form. Then after that, we go to the second step by finding the determinants. So we get the determinants. So the determinants is going to be this times this. So we say 2 times 3 minus 1 times -1. It's going to give us what? We get the determinants. We get the determinants. That pattern 7. So we get 7 here. So after getting 7, then we come to this original matrix, which is here. We want to get x. So when we want to get x, which is this value, what we do, we omit this. I get to the point. Instead, we replace this one with this. So we say that 7, 14. Then the y will remain constant. We say x will be equals to 7, 14, then -1, 3. You're together? Then we divide this one by 7, the determinants. We divide it by 7. So we want to get a value of x. When you're getting the value of x, now you take this particular product, is the one you're going to replace. Then this one remains constant. Then we divide everything by 7 to cause out. So after doing that, then we find out the determinants. So we think this will be equals to 7 times 3 minus 14 times -1. We divide by 7. Cause out. Now I repeat. The first step I said, first you construct the matrix form. Then after that, we get the determinants. You're together? Where it's going to this times this, minus this times this, which is 7. Cause out. After getting the determinant, the next step, now we want to get the value of x. What is x? Now we say x will be equals to. We replace this particular x now with this. And then this y remain constant, which is this one. Then we divide by what? 7. Then after that, we find the determinants of this matrix now. By taking this one times this, minus this one times this. Then we divide by 7. So x will be equals to you get it? Okay, the upper one is 35 over 7. So that's going to give us what? 5. So x will be 5. Now we come to the second part. Now we want to get y. We are together. So we say that y will be equals to. Now this particular element of y will replace with this. So it's going to be 7, 14. You're together? X remain constant. So 1. Divide by what? 7. Then we get the determinants of this. By saying that's going to be 7 times 1. You're together? There's negative somewhere. No? 7 times 1 minus 14 times 2. Divide by what? 7. Negative 21. So y equals to negative 21 divided by 7. It's going to be negative what? 3. Now after that, well, let's find out if what our answer is correct. Then we come here by saying, let's start with this. Is 2 times what? 5 minus 3. It's going to give us what?
Are you going to put
This is, we replace this one now with 5.
And what about the negative? Are you supposed to, like negative, it becomes positive and becomes a plus?
Okay, that's a negative. So it's minus 3. It's going to give us 13, which is not true. It's not true.
Here, when you are replacing 7, 14, are you not supposed to keep 2, 1 in the front?
This one. Oh, we made a change because it's y. It's supposed to be 2, 1, then 14, 7, 7, and then 14. Sorry. So that's going to be 2 times 14 minus 1 times 7. So it's going to be positive. Is it positive? Yeah. So this is going to be minus 3 to give us 7. Because now the second one is going to be, let's use this one, 5 minus 3 times minus 3 times. It's 5 plus 3 times 3. Give us what? 14. What's up? That is the grammar rules. Now, if you're told to solve, we can solve, we write inverse method. Inverse method. Inverse method. That's 2 by 2 matrix. So if you're told to use the inverse method, I want us to look at the example here. We solved by 2 by 2 matrix, for 2 by 2 matrix, for 2 by 2 matrix. We are going to use that. We're going to do it. No. Simultaneous. We're going to solve simultaneous using the inverse method. Just write the inverse method of 2 by 2 matrix. It's that question. Let's to go to May 2019, question 5. May 2019, question 5. So we are going to use the inverse method. Inverse method. Now, the matrix is this one. I hope you're there. Question 5. B. I think that is 4x plus 3y equals to what? 26. The second one is going to be minus y equals to what? 8. So we are not using the one, we just want to use ours. We are using the matrix method. So the first thing, we are going to convert this one in the matrix form, whereby we are going to have 4, 3, 2, negative what? Then you enclose with a bracket. Then you open another bracket, x, y. You enclose again, will be equals to 26, 8. We are using the inverse. Now the first step, we are going to get the determinants. So the determinants will be equals to 4 times negative 1, we are together, minus 2 times 3. Negative 10. We are together. So after getting that negative 10, our next step, now we want to get the inverse. What's the inverse? So the inverse is going to be 1 over negative 10. Because into bracket, we interchange this negative 1. We multiply this one by negative 1, negative 3. Multiply this one by negative 1, negative 2, then 4. Here together. Here together. 26 and 8 is this one. 2019, 2020 what? Question 5. Then after that, we take this now the inverse. Here together. We multiply by this matrix. The original matrix 4, 3, 2, negative what? 1. Then we open the bracket. X and y will be equal to. We take this inverse again. I get this inverse. Just a minute. We take this inverse here together. We multiply by what? The product here together. So that's going to be 1 over negative 10 into bracket negative 1, negative 2 together. Then negative 3, 4 right together. That's going to be, we open the bracket, 26 east. Get together. Right together. So after that, let's multiply this. This times this negative 4. Let's just write it here. Negative 4. It's 1 over, get together, into bracket, negative 4. Just, okay. This times this plus this times this. I want us to get everything. This times this plus this times this. It's going to give us what? This times this plus this times this. This times this was how? Negative 4. This times this?
6. Negative 6.
Negative 6. So negative 4, negative 10. What's how? You're together there? This times this, negative, plus this times this. It's going to give us? Okay. This times this, negative 3. Plus this times this, 0. Tuko sawa? Tuko sawa? Yeah. Sijui kama tuko sawa?
Yes.
Okay. Now I come to this. This times this.
Yes.
Plus this times this. You got it?
Negative root, it's a 0. It's a 0.
0. This times this.
Negative 6.
Plus this times this. Negative 10. You have together? So this is negative 10. X, y together. Then this one times this, negative 36 plus this times this. Negative 24.
It's not negative 50.
Negative 50. equals to 1 over negative 10, negative 50. See here? Come to this. This times this. Get together? Plus this times this. This times this plus this times this. That's 52, negative 52. This one, this is going to be 24, 25, 32. 32. Yeah.
So it's 20.
20, is it negative or positive?
It's a positive.
Positive.
It's negative.
Negative. Negative what?
20.
Negative 20. Because how? Now, this one times this is going to give us what? 1. You're together? Because these are negative 10, negative 10, positive 1. You're together. This one over negative 10. So when you take this one times this is going to give us 1. You're together? Then this one is 0. This one, 0. This one, negative 1. Because now, x, y. Are you together? Will give us what? This one is going to give us positive what? 5. This one? So then x equals to 5. Y equals to what? 2. Now we can find out if the answer is correct. When you take 4 times 5 is 20, see here? Plus 3 times 2, 6. That's 26. When you take this one, 2 times 5 is 10. Minus 2. It's going to give us what? 8. Because how? Huh? Yeah, you to my final side. Maybe write it fast. Okay, we look at another example. I want to go to May 7, 2017. May 2017. Remember, matrix, when you look at the first step on it, you are going to find that it should be the exam. So you must know how we solve it using different methods. Right now, I'm not talking about the method which are being applied. I just talk about now we look at May 2017, question 2, question 1.
Question 1.
Yes, question 1. C. Are you seeing that? Question 1, C? Yeah. It says a retail shop sold 2 types of goods, namely X and Y, in a given month, totaling to for 30 goods. Now, the cost of selling type X goods is 300 per item, while the cost of selling type Y goods is 425 per item. They're together. During the month, the total sales of type X and type Y goods amounted to 151,500. They're together. Then they want you, using a matrix algebra, determine the number of goods of type X and type Y. So what we do, first we construct our simultaneous equation. So the simultaneous equation here, they are saying a retail shop sold 2 types of goods, namely X and Y, in a given month, totaling to 430. So we say that X plus Y equals to 430. Then the second part, they're saying that the cost of selling type X goods is 300 per item. So you say 300X plus and 425. 425Y equals to, what's the total? 151, 500. That is the simultaneous first. Then the next step, we are going to have the matrix form because they want us to solve using the matrix. So we're going to say 1, 1. Then 425. We enclose, then X, Y. It will give us 430, 151, 500. They open it together there.
You can simplify the second one.
Okay, we cannot simplify this one. Why? Okay. You want us to simplify the second one? We can do. Can do that. Huh? Yeah, but we can solve it the way it is. Or we can simplify. So let's just use the way it is. We are together. So what we do the next step? We get the determinant. So the determinant here will be equals to 1 times 425 minus 300 times 1 to give us what? 125. Then the next step, we are going to get the inverse. The inverse is going to 1 over 125. We are together. Then you open your bracket here. It's going to be 425 minus 1. You might go by minus.
No, I was going there.
Okay, so this is going to be minus 1. Then we multiply by the original matrix, which is going to be 1, 1, 300, 420, then x and y.
That's how you get inverse.
The inverse we get it is here. This is the inverse alone. So we have to find out the identity matrix. By taking the inverse times the original matrix is going to give us identity matrix. They're together. The identity matrix where we have 1, 0, 0, 1. Then we take this particular inverse again. We multiply. That's going to be 1 over 125 into 425 negative 1, 300, 1. We are together. Then we multiply by what? 430, 151, 500. We are together there. Then what do? We take this one multiplied by this. So take this one times this minus plus this times this. 425 times 1 is 425 times plus, so that is 300. We are together. So 425 minus 300 is 125. 125 divided by 125, 1. So we are going to have 1. If you?
Like that, identity, like 1, the number, then 0.
Yeah, you can, if you know how to get the inverse, you just go and write that identity matrix there without even calculating. Because this one I just multiply for you to confirm if it's true. Because when you come to this one, this is 425 times this one. Ngapi? 425. Plus negative this times this. That's 425. So that is 0. When you come to this one, this is negative 30 times this plus 1 times this, that is 0. So everything is going to be that. So you just come here, you write 0, 0, 1. X, Y. So the place which is important here is this part. Hizi here tayari ukishapata hii vizuri, you know that's going to be, huh?
So automatically
yeah.
So
Yeah, there's no need. The only place which you are supposed to work for is this part. What's up? Now we come here, we take this 425 times this. Now, because this is a minus, just minus with this. 81. Then divide this one. 250. So this is going to be 250. 250, yeah. You're together. Let's come to this. You're together. So this one times this in a particular, remember it's a minus. Subtract. Negative. I think it's positive. I think it's positive because this one and this, I think this one is greater than 3 of the pattern.
Hiyo ya kwanza,
Tumesema
25 times
This one times this, ni ngapi? 25. Negative 129, like this. Now, when you look at this and this one is greater than this. That's what I would say. So you take this one minus this. It's going to be a positive.
you're not supposed to take.
You can just take this negative plus this one. Then divide by 125. 170? 176. So, it's a positive, it's not a negative. You say it's 176.
hiyo ya kwanza 425 times 430, sio?
See, 425.
425 times 430.
430. It's 430 times, it is negative 300 times 430.
That's what is 425.
425 was times this plus this one times this. We are together.
So 2 plus 151 500.
So the second one, the second row will be negative 300. 400
Yeah.
plus
1 times this.
this
Mm.
22.
22.
22.
Then divide by this. That's what we calculate. 180. Sawa. When you take this one plus this inakupata ngapi? Ndio hii. Sawa. I want you to do for me May 2016 question 1B. May 2016 question 1B.
7 times 46. 7 times 46.
7 times 4. You know, you got the 5.7. Ja, geef ze dat.
Ja? X.
ECSE 05414 or 14P. Is er wat is er wat? Ja. Is er al dat zo best? Nou, moet zo wat dan.
X 15, Y 320.
Alle. Maar en waarom hij? Bakker? Anders gaat er in 3 minuten of zo.
Si markup income profit. Amesema A peke yake. Amesema A peke yake. This one. Amesema tufanye DB Roman case.
See, okay, when you confirm, it's okay. Yeah, Roman 12. Now the selling price of a queen cake and a black forest. Now let's look at that. The bakery makes a markup of 20% and 30% on queen cake and black forest respectively. So it's a markup. Okay, what's the price of a queen?
Each.
Yeah, each. Queen cake. Fifth one. And then black forest. 320. So if these are the price per unit, these are the price per unit, and they are making a markup of 20%. 20% for queen cake. Because now, so the selling price per unit, selling price will be equal to 150. That is for queen cake, plus 20 over 100 times 150 plus 20% of 150, because that's a markup, not a budget. Here is a markup. Yeah. So that's going to give us what? Money. Then for black forest, that is for queen cake. Queen cake. For black forest, selling price will be equal to 320 plus 30 over 100 times 320. Ngapi? 460. We hope that together there.
It was imagine below.
You convert it to markup. Let's just do this one together. November 2018. And then that's the end of our matrix. Question 1. Now this one, they want us to use a matrix. So we are going to use what's known as so let's look at we are going to use the Cramer's rule method. So first, they are saying a manufacturer produces two commodities, X and Y. In September 2018, the manufacturer produced 5 units of commodity X and 6 units of commodity Y at a cost of 24,400. We are together? So it's going to be 5X plus 6Y. Okay, a manufacturer produces two commodities, X and Y. Those are the commodities. In September 2018, the manufacturer produces 5 units of commodity X and 6 units of commodity Y at a cost of what? 24,400. We are together? Now, in October 2018, the manufacturer produces 7 units of X and 9 units of commodity Y at a cost of what? 35,600. You're together? So they want you to first let's find out. The first one is 5X plus equals to 30. Now the second one, 7X plus 9Y equals to 35,600. Then we are going to convert this one into what? Matrix form. That's going to be 5, 6, 7, 9, X, Y, they're together, equals to 2, 4, and then 3, 5. You're together. Now I want us to use now you come to the second, using matrix algebra, compute the cost of producing each unit of commodity X and commodity Y. Because how? So in this case, we find the determinants. It's going to be 5 times 9 minus 7 times. That's what you're happy. 3. Positive or negative? Okay. Now after that, I said you're using the Cramer method. Now we get our X. X will be equals to 2, 4, 400, 3, 5, 600, then 6, 9. You're together. And that will be the same, divide by 3. So will be the same as 2, 4, 400. You're together. Times 9 minus 3, 5, 600 times 6. Divide by 3. Manufacturing ngapi? This one. I take this one to replace these values. That's it. Cramer's rule.
So you're not using inverse method at all?
Huh?
You're not using
We can use inverse or Cramer's
Any.
rule. Yeah, any. 2000. What's up? Now let's get y by saying y will be equals to 5, 7, 24, 400, 35, 600. Divide by what? 3. And that's going to be equals to 5 times 35, 600, minus 7 times 24, 400. Divide by what? 3. So y equals to what? Two thousand 200. 400. So we can just come here to test if it's true. When you come 2 times 5, it's Mikape? 10. 10 times. Yeah. And then 6 times 2,400. If you add, sorry, Apple. Because when they say use the matrix method, you can use any. But when they specify it, then you must use that. Sorry, Apple. Now, tomorrow we are going to start a topic known as calculus. Matrix tumemaliza.